So welcome to the Pigeonhole Principle series. In this series, we'll be talking about the Pigeonhole Principle, of course, otherwise known as the Drawer Principle. So first, it's easy to understand what is the Pigeonhole Principle. Imagine that there are two pigeonholes, so basically just like places to contain pigeons. There are three pigeons, pigeon A, B, and C. They're circles, but just imagine them as pigeons. And I'm trying to put them into the drawers, not evenly, and as you can see there are only two drawers for three pigeons. So I have pigeons A and C in the first drawer and B in the second drawer. But of course I can always switch, I can always switch the number C bird over here, B over here, and A over here. Or I could have all of them in the same pigeonhole. So now I'm going to ask you a question. How many pigeonholes are there? Well, there are two pigeonholes. And how many pigeons are there? Three pigeonholes. So the pigeonhole principle says that okay, says that the number of okay, so it says that the number of pigeons, so in this case 3, divided by the number of pigeonholes, which would be 2, and after you divide that, that would be 1 remainder 1. You would get at least two pigeons in one drawer. And here's how he got that, how the mathematician got 2. So he would take this 1 here and then plus 1 from over here. That was a remainder, which equals 2. So there would be at least 2 pigeons in one pigeonhole. And now I'm going to prove that. So this would be drawer number 1 and drawer number 2. Alright, so in this first case would be all 3 pigeons are in pigeonhole number 1 and there are 0 pigeons in pigeonhole number 2. Another scenario would be 2 pigeons in hole 1 and 1 pigeon in hole 2. Then of course this would be 1 pigeon shown over here in hole 1 and 2 pigeons in hole 2. Or there could be no pigeons in hole 1 and all 3 pigeons in hole 2. So let's first look at the largest number of each pair. That would be 3, 2, 2, and 3. These are all at least 2. So if all of the pigeons are all in one drawer, for example, 3 and 3, that would be more than 2, but the smallest it can be would be just 2 itself. It can't go any smaller than that. So what this is saying is that there is at least one drawer with at least 2 pigeons. Sorry, if I used the word drawer, it was supposed to be hole. Okay, So notice how I use the phrase at least 2 times in this sentence. So remember, it's 2 times. It's not that both of the drawers have at least 2 pigeons. It's at least one hole has at least 2 pigeons. So that's something you should know. But does this happen with anything else? So let's try some more scenarios. Say there were 7 drawers, and there were 3 pigeons. How many pigeons will be in at least one hole? Well, we would just do division, which we get 2 remainder 1. So then we would do 2 plus the remainder 1, which equals 3. So there were to be at least one hole with at least 3 pigeons. So that makes sense. Let's try another one. For example, 8 pigeons. Sorry if for the other one I said 3 pigeons. There was actually 7 pigeons on that. Sorry, it's just a misconfusion. So this is the number of pigeons, and this is the number of holes. Okay, that would be okay. Just it was a mix-up on the last example. I'm sorry. Anyway, after you do this, you would be 2 remainder 2. But so do we do 2 plus 2 and equals 4 maybe? Well, let's try, okay? So you could do this by yourself. After trying, you'll see that it's not always like this. It's not always at least one drawer has at least 4 pigeons. Sorry, at least one hole has at least 4 pigeons. So what could that mean? Well, another way we could do this is if you see what's going on right there, just add 1. There's always at least one drawer with at least 3 pigeons in there. You can go and try out the experiment. So why 1? What went wrong there? Well, the reason is because now that you know why this is, here is the actual rule. So the principle says that if m divided by n is equal to a remainder b, then there is always at least a plus 1 pigeons in at least one hole. Alright, so that's 1. Now let's try without a remainder. For example, 6 pigeons being divided into 3 holes. That is just, 2. So that would be for whole numbers, for whole quotients, that would be if m divided by n has no remainder b and just a, then it would be at least a pigeons in at least one hole. So this is the other one. So now that you know the principle, we are going to look at how to solve some word problems of these. Well, we could, so there's always 5 steps to this, okay? this very first one would be find what are your holes. So in these problems, they're not just going to be about pigeons. That would be way too boring. They're going to have diversity, so it's going to be different types of things. Sometimes it wouldn't even tell you directly in the problem. So first find the holes. Then you're going to want to find the pigeons. How many pigeons there are, how much pigeons are there. Then you're going to solve. Well, first you're going to have the equation. Divide, and if you have to, add. And then finally you would answer the question. So these are the steps that you'll need to know throughout this series. So it would be a good time to write this down right now, so it will be more efficient for the next few problems. So thank you for watching this video, and see you in problem 1.